Hi everyone, welcome back to the advanced track. And the next session will be about how Spotify is using Beam using Scio. So I'll give the word to Julien now.
Hey guys, thanks for coming. Is everyone there already? Yes. Okay, so I'm going to introduce myself. I'm Julian. I'm a data engineer at Spotify since March, fairly new there. I've been a Scala developer for like 8 years or so, and I contribute to various open source projects. And by the way, I'm French, even though I live in Sweden, so if anything I said you don't understand, just shout at me, okay? All right, so what is Spotify? Who is using Spotify? Survey. Yes. Who is not using Spotify? Why? I'm looking at you, people. Yeah, so as most of you know already, Spotify is a music streaming platform. We have, I think that's slightly old stuff. I think now we have 200 million active users every month. We have about 83 million subscribers, probably a bit more now. 35 million songs that you can stream, and about 2 billion playlists. So we have data. A lot of data, actually. So does any of you guys know what this is, what that picture is? No one? Really, great. So I get to tell the story. So this guy over there, who's really happy about what he's doing, is an engineer at Spotify back in 2009. And that piles of machines that you can see there is Spotify's Hadoop clusters. So what's happening is in 2009, Spotify has this very nice Hadoop cluster that is installed into the football room somewhere. And it's in Sweden. And that guy at Spotify is running Hadoop jobs on it. And at some point in the summer in Sweden, he realized that quite often the jobs are actually failing for some reason. What is happening? So he's looking for solutions, and he noticed at some point that it's only specific servers that are failing. And it turns out that the servers that are failing are the ones on top of the pile for some odd reason. So they investigate for some time, and they realize that actually what happened is that summer 2009 in Sweden is very hot, and those servers just by the window, and the sun, when it's rising, goes right on the servers, they overheat, and the jobs are failing. So that's a bug fix right there. So what they did is I took like that, I think it's like linen or something, and they taped it on the window so the sun don't go on the servers, and bug fixed, yay. Successful release in production, great. So that was fun. That means that Spotify at some point had a lot of servers for their Hadoop clusters. I think at some point Spotify had actually the biggest Hadoop cluster in Europe. That was about 2,500 nodes, something like that. And no, we don't have it anymore because we're using Beam and Dataflow. So why do we do that? Right. So those are the reasons. I guess the bottom line is Spotify figured out that it's a better use of engineering time to work on features on Spotify, improve the user experience, get new interesting playlists to be generated, things like that, instead of spending time fiddling with the many knobs of the Hadoop cluster, right? Does it make sense? Yes. So why do we use Scala then? There's a nice Java API and Python API. Why would you do that? Well, because we like it, first of all. But basically what Scala gives us is a nice higher level DSL, specific language. It's pretty similar to what we can do with Spark and Flink. So if you guys have used that, the API is going to be fairly similar to that. It's functional programming. Who knows what functional programming is? Everyone? Good. Functional programming is really good when it comes to writing data pipeline because the model actually fits what you want to do on a pipeline. For example, you don't want to have a global mutable state. Well, you don't do that in a functional program. So Scala is a good fit. It's natural. Programming in Scala for pipelines is a very natural model. And there's a bunch of interesting libraries. And also, Scala gives you macros. Who doesn't know what a macro is? OK, a couple of people. So quickly, macros are a way to plug code in the Scala compiler. So basically, you can get the syntax tree of your program, manipulate it, generate code, do whatever you want. And you can do that in Scala. You can't do it in Java. And Scala also has like this library called Checklist, which is fairly fun. You should check it out. I won't go into that. All right, so we developed that library called Scio. It's pronounced Scio. It's a Scala API for Apache Beam and Google Cloud Dataflow. And it means I know, I understand, I have knowledge. And it has an I/O at the end, because that's what all the good kids were doing 2 years ago. And it's open source. So you can go on the Spotify GitHub and check out the code, hack with it, make PR, please. Read the documentation, whatever, anything you want to do. By the way, Spotify has a lot of open source projects, like Luigi, Annoy, a bunch of other. You should definitely check out our GitHub. Right. So what is Scio? So this is how Scio works. Basically, it sits on top of the Java SDK in Dataflow, and it gives you a Scala API, and it also gives you a bunch of other goodness. I'm going to demo some of them. Who use that at Spotify? So we have 3 types of users at Spotify. Data engineers, obviously, data scientists, and backend engineers. So the things that is important to know is that data scientists typically are not like super extremely good functional programmers with 10 years of experience deploying solutions into productions. Generally, they're more interested in math, not really coding. Backend engineers, generally at Spotify, they like Java. They write Java code. They're great engineers. Not a lot of experience with Scala, but sometimes they have to write code for pipelines for some reasons. And data engineers, generally, well, they know what they're doing. That's the job, right? They should know. But maybe they've used Python. So the point is like Scio should not be too hard to use for all those people. They have different level of knowledge. They don't want to spend 10 years knowing what Haskell is so that they can use a very functional API in Scala. Then it's something that is functional but easy to use. All right. I don't remember what I'm saying next. Oh, yeah. OK. So that's an example code in Scio. That's word count, very original example, right? Someone's talking to me. So I guess, who has used Scio before? Right, only a few people, good. Who doesn't understand what this does? No one. That is the point. You have never seen Scio's code, and yet you understand what it's doing, because it's easy, right? So yeah. I mean, the top line is important. We get a context. If we want to do anything, we need the Scio context. I think Spark does something similar. Then you read a text file. You filter empty lines, you split on words, and you combine value, and you save that somewhere, and then you close, which actually run the pipeline. Great, that was easy. By the way, that looks exactly like the collection API in Scala. You could take that code, replace the sctext file by a list, and that works too. Next, Scio gives you a bunch of funny things. For example, over there, what we see is that we type SQL queries, that is using BigQuery, and there's a class. And look, there's no code, because what Scio is doing is that it's going to generate code for that class using the BigQuery schema of the table, so that everything you do with that is actually type safe. You can't mistype the name of your column or something. That wouldn't compile. You can do it the other way. You can take a class, say, write that to a table, and then that works too. You don't have to give a schema. Scio does that for you. And we have that thing, a REPL. Everyone knows what a REPL is. Yes, cool. I'm going to demo that. OK, I hope that works. OK, can you see that thing? Ooh. Yes. So there's this small program called the Scio REPL that you can install in like 10 seconds. And what this is a Scala REPL that you can use. And it starts by giving you a Scio context right away and a BigQuery context so that you can use Scio and BigQuery inside that repo, right? I should have pasted the program. Yes. OK, so that is the word count. I can zoom a bit more, maybe. Yes. And I'm going to run that. And locally, and hopefully I have internet, because otherwise it's not going to work. Please. OK. Come on. OK. That should OK, so it should go to Google Cloud Storage, get a file, count word, exit, and give me a list of the results, or an iterable on the results. But apparently, the internet is not working. All right, moving on. Yes, no, it's working, actually. Great. OK, so it's going to get that file, which hopefully should be fast. Please. No. All right. Anyway, the point is, oh, yeah. OK, so it gives me that thing, res2, which I can convert to a list. Look at that. It's a list of words and the number of times you've seen them. Then I can do, I don't know, res3 dot sort by. Let's say the number of times they occur, right? Take 10, then let's say for each, oh, look, completion. Print that thing. Yay. So the most common word is the. Exciting. All right. Now what I can do is this, which is passing new arguments to the Scio REPL, and I say, what about using the Dataflow runner, right? That should work. I can say, give me a new Scio context. Pass my program again, run it. And now it's running on Dataflow. Ooh. Dataflow should be nice enough to actually, hello? Where's my pointer? A URL where I should see everything. Let's see, console, Dataflow. I just want to prove that it's actually running. Yes, that's my thing. Yay. All right, cool. It's running. I'm not going to wait for the result because you've seen it already. OK, back to the talk. Yes. All right, so Scio gets you, well, something that'll just beam, like this nice diagram. I don't know if you've noticed that, but it also gives me the name of the function that I was calling in my REPL session. I have access to all the IOs. And on top of that, we had like a bunch of optimization on join. We have hash join and a bunch of other joins that you can use if you have faster joins. And it gives you like an API for metrics. Another demo. Woo. What is this one? All right. I want to demo how you create a Scio project because that's easy. So you do this. SBT is like the build tool for Scala. It means simple build tool. It's not that simple. But it's simple enough. So what this does is that it's going to go on GitHub, get the Scio templates, start a new Scio project for me. So I'm going to call that demo, Spotify. Yes, can cd demo. And there, I actually have a project. Zoom on that, main. I'm going to zoom because no one sees what I'm doing. Right, Scala word count. So I actually have already a word count pipeline. Great, that's not what I want to demo. So I'm going to type really quickly. Oh, look, new program. That was fast. Yeah, I'm very productive. So here's what this does. It goes into BigQuery. There's public data sets of GitHub commits, which is fairly big. You go there, find all the commits for Scio, and gets you the name of the committers, right? And this program goes there and count the number of commits for each committer. And the thing that you should notice now, I hope, is that I can build that thing. Can you go down? Yes, go away. Scio is generating the GitHub class for me, like I showed a few slides ago. Now I can go and compile, and that should work. Hopefully, compiling. The Scala compiler is very fast, or not. Come on, generating a class. It's compiling. Okay, so what if I actually mistype this? What if I say, that's an awful? Compile. Oh, doesn't compile anymore. I haven't run the pipeline yet, right? Okay, that's way faster than trying to run the thing. I can package that thing. So there I have a package that is ready that I can show you into cd targets, pack. I have something that gives me a bin that I can run, and it's ready to be executed. But I can also just take that code that I've prepared, because I'm very smart. There, say, hop, run main, pass parameters. Whoops. Yes, because don't type SBT twice. That's stupid. And, whoops. And I broke something. Yay. Oh, yes, I forgot to do something. What I'm going to do now is update Scio, and because I like risk, I'm going to use the alpha version. Whoops, Aloha. And then I'm going to go and add the Dataflow runner, and then I'm going to go and add BigQuery support, although I think it's actually pulled already. Still adding it anyway. Reload. Yay. Run. It's compiling. And that time is going to work. Yes. So now my job is running on Dataflow. Or will be. Yes. Right. That was easy. And I'm using the alpha version because I'm an idiot. Next, moving on. I'm going to let that run for a while, because why not? And that was my second demo. Next. So, how many people are actually using that thing at Spotify? We have roughly 300 users using Scio. I don't know the exact number. 300 is the number of people that are actually on the Scala channel at Spotify, so maybe more. Who knows? We have roughly 3,300 pipelines, batch pipeline running in production right now. 1 year ago, we had 70. Most of the pipeline we are writing are actually written with Scala and Scio. And we use it for both batch and streaming jobs. We know that like roughly 10 big-ish companies are using Scio, although they don't want to talk about it, but they do. All right, so the current version of Scio is 0.6 something. In the next few days, we are going to release Scio 0.70, which is for the first time release where we're actually breaking things. Sorry. But what we did is like bring a new bunch of good stuff. We actually refactored how Scio is doing IOs. So it makes it a lot easier to actually add new IOs to Scio. And you get, if you do that, you get test support out of the box. Before that, you actually had to like do the proper thing so that test would work with your IOs. No, it's way easier. Each IO is actually in its own sub-project, so you don't have to import BigQuery if you don't use it. And it supports, yeah, we can add source and things. And the other big thing is, the one that breaks all the things, is coder derivation. So that's pretty good. So who knows what a coder is in Beam? Yes, most people, because they had problem with them, right? Okay, no, I'm just kidding. But, oh, there's a typo here. Derivation, what's this? That's derivation, obviously. Coder and Beam are used when you want to serialize data to move data between workers, right? So basically all the times. How that works right now in Scio is that it's using cryo and chill to serialize data dynamically. So at runtime, it's sort of like try to figure out what you're trying to do, serialize the data, send it somewhere. Good. That's cool, but we can do better because we're using Scala. So what we did with the new version of Scio is that for most cases, Scio is able to actually generate the code at compile time. You don't have to do anything. Like I was running Scio 07 on my demo. I didn't talk about coder anywhere. It just worked. It worked at compile time. It's safe because it's compile time. It's fairly predictable because you know what it's doing without having to run the thing. And that means that you can generate fairly efficient coders, right? All right. Demo again, yay. Who wrote those slides? Huh. Okay, so here's what I'm going to do. I'm going to go into my project, launch SBT. Drink a bit of water while it's launching. Type console. All right. That thing. And now I have a Scala console in the context of my project, right? So here's what I'm going to do. I'm going to import coders. Not those. Yes. And I'm going to ask Scio at compile time, give me a coder for integer. Yay, it exists. It's a Beam coder. Great. Can you give me a coder for list of integer? Whoops. Yay. Yeah, that works too. Oh, by the way, that's a Java integer. OK, what if I create a class called foo that have s, which is a string, and then I, which is an int. Right, can you give me a coder of foo? Yes. That's compile time, right? I haven't run anything. What if I say Java, those pesky Java classes? Oh, we cannot do that. So it did it anyway. But it says, I couldn't really find a coder for local. I don't know what that thing is. So instead, what you should do is write one yourself, and it gives you the code you should be writing, right? With question marks, because it doesn't know what it's supposed to do. But in the meantime, because we don't want to break everyone's code, we provide you a fallback, and it's going to use cryo, like it used to do. But when the times come, maybe you want to implement a proper coder for that thing, because that'd be probably safer. OK, what if I say a list of those things? Right? That's where it gets hard when you do that in Java, because in Java you do that at runtime, and runtime you don't know that at least contains locals. It contains things, right? Do that. It says, well, I need a coder for local. Yes, but it did find out that it knows how to serialize lists. I don't have to say that. So I have an efficient coder for list that uses the fallback coder for locals. It also works for guest classes. If I say that that thing is actually local, I say find me a coder of foo. Yep, that also works. It also tells me it's only missing the local. It knows what to do with strings. OK, cool. And that was my demo. I hope you're impressed. OK, I think that was the last demo. I hope so. All right, I'm going to go quickly through a bunch of use cases that we have at Spotify for Scio and Beam. Find insights. It's something that we do for artists. It gives you info about who's listening to your song, where, when, why. It uses GCS, and it has, like, it went from a Java pipeline that was 150 jobs to 10 Scio jobs. Yes. We have this one, top songs. You know what this is? No? Yes? One guy? Yeah. OK, so that is, that's a playlist that generated once every year and tells you what you've been listening for a year. What are your favorite songs, the thing that you will be listening probably again. So that one is interesting because if you want to do that, you have to go through 1 year of history. And at Spotify, that's a lot of data, actually, quite a lot. And then you have to join that with the info about the songs, who's playing the songs, because you only have an idea when you're publishing the event. And it has pretty complex rules, like you don't want the same song twice, because there's like the live version and the studio version. And you want to make sure that the song is actually available in the country where you are. There's like a bunch of different rules like that. And the other thing is because we run that once every year, we basically change it every time. So you want something that's pretty fast to run, because otherwise, if it takes 5 days to run it, you don't really have the time to experiment with it. Yeah, so pretty interesting use case. Next one, this one is pretty funny too. Master metadata. Master metadata at Spotify is all the infos we have about songs, of course. So that's not a huge data set, all right? It's only like 70 million records, not big. But it comes from 26 different people that have all different formats and stuff. And we have to make all that like a unified format with the same kind of data in it. So that's actually quite a lot of work. When you run it, it looks like that. Yeah, that's a big pipeline. Yeah, I don't know. I'm not writing that thing. I guess not. I hope not. The question was, are there bugs? No, of course not. Listening history, so that's like generating your listening habits. So it says like, that user has listened that songs 5 times in the current month, that kind of things. It's got 240 terabytes of data from BigTable, turned that into 90 terabytes on GCS. So that's a pretty big job. We have that pretty cool stuff called BigDefeat. That thing is like a job that you take 2 different data sets, and it tells you how different or how similar they are. And that works for big data sets, right? Hence the name, BigDefeat. Gives you info about deltas and stuff. There's 2 use cases that are interesting. First one is when you migrate pipeline to Scio. Say you have a Hadoop pipeline, you don't have much test, but you know it works. You rewrite it in Scio, you want to make sure it's not breaking anything. So you can like generate a data set for, say, an hour, a month, and then you compare it with what Scio gives you, and it has to be the same. Or generally it's not the same because one of the 2 pipelines has bugs. You can also use it to work on machine learning models. Say you have a machine learning model, you generate data with it, you tweak it a bit, you want to see how it changes the output. You use BigDefeat. So use it like this. That's how you migrate to Scio when you have a legacy pipeline. And we have like a bunch of other use cases. What is out in Scala? Serialization is pretty funny. Just like in Java, just worse. But we deal with that for you, mostly. And IntelliJ support is not always great. We actually had to write a plugin for IntelliJ so that it supports Scala macros properly. And that's all I have. Thank you. Do you have any questions?
Any questions?
So I noticed you went from having every source and sync be able to be .read whatever to having more modular version. And I'm wondering how that impacts discoverability and stuff like that.
Come again? Not sure I get the
question. So you said you're moving your sources and syncs into more. Each one's its own module. Instead of having like global object has like read text, read query, etc.
Yeah.
So how does that impact discoverability?
So that's something that was there already because in previous version of Scio, we didn't have, like you had to import some modules for some IOs, but for some other IOs, it was just like transitive dependency pulled by the core. So you had it already. So it's just more natural now. Like if you're using BigQuery, yes, you need to add the BigQuery support. So I guess it's fairly logical. Anyway, if someone has an issue, we can answer on Slack and on the mailing list and on Gitter and on Scio's issues. So I guess that shouldn't be a problem. And it's documented anyway. So I guess you're good. By the way, we wrote a migration guide that tells you what you need to do when using Scio in older version to get to 0.7. More questions?
Okay. Do you plan to put Scio as a fourth SDK for Beam available, or are there any plans? Because it's obvious that there's the Scala implementation of Beam, or
yes, so we are discussing that. That means Scio would become an Apache project. Yeah, we're talking about that. It's not there right now. Maybe in the future. I can't really tell you right now.
So Spotify made a decision to go to Google Cloud. How do you test your pipelines then? Do you use Dataflow as well for testing?
Yes, so Scio has like testing supports. So the Beam API also has that, but if you use Scio, you have like something specific to write unit tests for your pipeline. You can also write integration tests. It's up to you. You can use Beam API if you want to. There's different method. I mean, it's largely up to the squad that is supporting the pipeline of Spotify. They deal with their pipeline. We just provide the tooling.